Welcome to our video presentation. We are Group 5 and our vehicle's name is the Transcender.
Hi, I'm Akash. I'm part of this group and I've worked on the market conditions, future market conditions and manufacturability of our future vehicle.
My name is Rishi Kamath and I'll be presenting to you the technological requirements that are required in the vehicle of the future, the new technologies that we want to incorporate in our vehicle, and how these will affect the safety and the drivability of the vehicle.
My name is Seth Gordon. I will be talking to you about the user interface and the interior of the vehicle, all the designs that go inside to make the vehicle more comfortable for the consumer.
My name is Alex Johnson, and I worked on the styling of the vehicle and all the things on the outer body.
I'm David Bookout, and I worked on the fuel and the fuel supply of the vehicle.
And we'll begin our presentation by discussing the styling of the Transcender. This is our proposed design. It's very sleek, shiny. As you can see, it doesn't have any flat surfaces. It's like a wave across it. It's a convertible SUV. It's got this front plane on it. This is a car in a wind tunnel. This is actually how they find the aerodynamics of the vehicles. Sometimes they use wind tunnels, sometimes they use an algorithm based off a 3D scan. But basically, vehicle designs in the future will be based off aerodynamics and how fluid dynamics and stuff pass through the car. This is the chassis multi-body design. The frame of cars in the future are going to be the same. It's just going to be a flat surface with wheels, and you can actually interchange bodies of the vehicle from day to day or whenever you want to if you have the money for stuff like that. Alright, this is just a diagram of a really nice car with the flipping up doors. That's beneficial for multiple reasons. Like in a parking lot when you're getting out of a car, you don't have to open outward toward another car. If there's a tight space, it just opens straight up. It also helps with the aerodynamics of the car. This is an example from the past when they first started trying to incorporate aerodynamic features into cars. These are tail fins. They look really cool, but they actually help get more miles per gallon. And then here's a tail fin in the future. It looks kind of like an airplane or like a spaceship, but it's got these side fenders and then this tail fin to help split the air as the car passes through. Alright, and then LED lights are part of the styling too. They're very effective. You can turn on each individual light on the car, so when you're passing through another car, it can turn off the lights so the other car isn't blinded. It'll be lined with LED lights so that they can turn on and off at any time. You've got the floodlights too and the straight tail lights. The back lights will be the same way as well in red, and they'll indicate how fast the car is slowing down as opposed to just that they are slowing down. Alright, and this is just a wheel with LED lighting to help the car be more visible at night. This shows how there are wind collectors. This is the front. The air goes into there and splits it so it doesn't hold back the car. It also helps cool down the engine. And this part right here on the sides, actually air can flow up through there and go out the top. And it also splits and disperses throughout the wheels so the car isn't slowed down by air. Now Seth will present the sizing and the interior of our car.
Hello, I'm Seth. We'll be introducing the sizing and interior of the vehicle. Sizing of vehicles have many designations. For our vehicle choice, the Transcender, we have decided to incorporate the SUV designation of the sizing. Our vehicle will have autonomous technology, which will allow the passengers to ride inside the vehicle without having to operate it. This technology will have sensors located throughout the vehicle that will help assist the vehicle to sense any vehicles in its surroundings or the outside environment. The vehicle dashboard is a very important component in the interior of the vehicle. This component will have control over every major function of the vehicle inside the interior, as well as a few major functions on the exterior as well. The interior lighting will light the entire cab. There will also be multiple colors that the lighting can produce, which will actually help to calm or relax the driver while they are operating the vehicle. The vehicle seats will have the ability to rotate. This will be good when entering the vehicle, as well as when the vehicle is in the using the autonomous technology. The passengers will actually be able to rotate their seats completely around and be able to communicate with other passengers inside the vehicle. There are many other interior designs we will present into our vehicle that will maximize the comfortability of the vehicle, as well as have the most high-tech innovations of this time. Thank you.
Here's David to present the engine and design components.
Okay, some advantages of our engine are we have electric battery capabilities, and the motors have high torque, so that gives improvement in acceleration. There's much more space in the vehicle because the batteries are smaller than regular engines that most cars have, so that's reduction in weight and space for other components to be introduced. Some disadvantages of engines are electric batteries do not hold very much energy themselves, so capacitors are starting to be introduced to help store and generate energy to send to the batteries. Some of the batteries are big, but as time goes, technology and stuff will bring the battery size down. Some fueling along with the battery I just mentioned. We have a lithium-ion battery. They're starting to hit the market in hybrid vehicles. They're also found in phones and laptops. So it shows that there's been a lot of research and work with these type of batteries. They perform well in high temperatures. We have the ability to plug in at home and have an adapter to take with you if you need to plug in anywhere else. I mentioned capacitors before, so our vehicle has electric capability, and with that we need a capacitor to help with the energy production and storage. Maintains power throughout, and it gives our hybrid SUV a little more boost needed on the road. This is just a picture of the inside design for lithium battery components. Ours also has a motor engine, so this isn't quite the same, but the lithium battery and the charger outlets in the back and on the sides is something that we would have. The other part of our hybrid car is gasoline. Approximately 93% of fuel used in transportation comes from petroleum oil. That's still going to be around in the future, so we think that given the customer the ability to use gasoline along with electric power will be more efficient all throughout the roads.
Akash will now present manufacturability.
Hi, I'm Akash, and I'll be talking on manufacturability and market conditions and future fuel pricing. So manufacturability, under the consideration of cost, time, reduction of cost, and we have focused on design of manufacturing and design for assembly. So design of manufacturing is the principle which eliminates and simplifies or standardizes the design and manufacturing processes. So in design for assembly, we have simplified techniques for products focusing on parts count reduction and also elimination or integration of parts or variant variant reduction, thus improving the product quality and assembly problems. So most of the problems in assembly are caused during design or manufacturing. So accumulation of these errors occur in different stages like design, manufacturing, and assembly. So here is the pros and cons for design, for pros and cons comparing the advantages and disadvantages between integrally designed and individually designed. The only disadvantage in integrally designed required is the design for manufacturing and design for assembly in advance, that the complexity of design, the disadvantage for integrally designed parts. So next, I'd like to talk on platform commonization. As you can see, the picture shows the front structure, the front underbody, and rear structure. Here, the joints between these three sections are called weld lines. So an ideal common platform is one which can accommodate set of different car models without any changes in components, assembly process, and module interfaces. Commonization can be useful in reducing product assembly cost and time. So platform commonization can be divided into two types. Commonize different platforms into a common part to support the individual platforms, or evaluation of assembly processes and plants that can be used to assemble the platform. So we move ahead to the market conditions. So I'd like to talk about different fuel prices. The cost of fuel for any alternative vehicle will be dependent on factors such as the cost of the original fuel, that is the crude oil or gasoline, and source from where it is coming, or natural gas or biomass, coal, etc. So this graph shows us the increase in prices for E85, for propane, for diesel over the last decade. So, and moving on, the fuel economy. Fuel economy, with a larger vehicle, one has to pay extra for the large extra material used on the vehicle, as well as the extra fuel needed to run your vehicle. So the average age of automobiles is now estimated to be 10.8 years. So the average age of trucks is evidently greater. So EIA provides us a summary. Yeah. Okay. So this forecast picture shows us from the report from McKinsey and Company report, where the total cost of ownership for vehicles in Europe is based on the confidential auto company data, which gives us the estimates for SUVs, the battery electric vehicles, the plug-in hybrid electric vehicles, and the diesel IC engine vehicles. So the market condition is explained keeping cost as our focus. The prices are showing some differences in according to the fuel types, and how would the various fuels be priced, and the fuel vehicles types like electric vehicles, biofuel cars, diesel cars impact the market conditions. Thank you.
And here's Rishi to discuss the technological requirements.
Hello, my name is Rishi, and I'll be talking about the technological requirements of a vehicle. Now, technological requirements are necessary because they take into consideration the safety requirements, the drivability, and the performance of the vehicle. Most of our technology that we are incorporating in the Transcender would be focused towards safety And certain technologies that are already there in the market, but we thought which were essential for a vehicle, we're putting them in. So first I would like to talk about the collision prevention technology. Now, this is a technology which is very basic and which is very important in a vehicle for safety considerations. It uses a technology called DDD, which is dosing driving detection. It detects the erratic movement of the car and the driver actually. What it does is it takes a reference line from the path of the vehicle, and then as and when the driver drifts from the reference line, it calculates the difference between the reference line and the path of the vehicle, and due to certain statistical analysis, it does certain, you might say, notification to the driver, or just gives the driver an indication that the vehicle is drifting, and then wakes up the driver if he is dizzy or if he's dozing or something like that. So here we will be talking about that. Next would be the traction control. Now, this system uses the sensors which are used on the ABS, that is the anti-braking system. Here, it takes into account the rotation speed of the wheel, and to see if the rotation speed of one wheel is more than the other wheel. And the sensors then check if one speed is rotating at a maybe higher speed than the other vehicle, and if it does, then we are going to apply a braking system wherein the speed is reduced back to the normal level of the other wheel. And also this can be done by another method, which is reducing the engine power to the wheel so that the speeds get normalized. And this can be done also by using a conjunction with the powertrain, which will again help in reducing the speed of the one wheel to the other wheel to avoid slip or lose traction. Another point I would like to talk about is the adaptive headlights. Now, regular headlights, like when a vehicle is moving in the straighter direction, the headlights would point, the light would be in the direction of the vehicle, and there wouldn't be any light falling on the side. And suppose the vehicle is taking a turn. So the light would be falling on the side of the road rather on the road, which is very much essential. And consider maybe a completely non-lit light where there is nothing else but the aid of your headlights, and you would like your headlights to fall on the road rather besides the road. So adaptive headlights is a solution for this, wherein there is an electric sensor that detects the speed, the steering angle, and the yaw of the vehicle. Now, these sensors detect if the vehicle is taking a turn, and if it is, the electric sensors detect change the orientation of the headlights onto the road rather than side of the road. And here they have a 15-degree range from the center point to one side, so we would have an overall 30-degree range, so that the vehicle could, the headlights could point towards either the left or the right, depending on whether the vehicle turns. Another very useful concept over here used is the self-leveling system, wherein the vehicle, the sensors detect if the vehicle is moving upward or downward, and suppose if the vehicle is going on a bump, then the vehicle will be pointing in the upward direction, and the self-leveling system detects that the vehicle is going in the upward direction and then would direct the headlights onto the road so that the vehicle, the driver does not lose sight of what is coming in front of him, and this would help in preventing a possible collision. And another addition to this technology is the adaptive brake lights that are used. This will give the driver at the rear end to understand what intensity with which the driver in the front would be braking. So if the driver senses a very strong light that is coming from the brake light, then he would apply a countermeasure to see that he doesn't collide with the car in front. So this would be a very important addition so that collision can be prevented. Now, airbags have been used in vehicles for like 50 years, and it has been like the most basic feature of a vehicle. But statistics have shown that almost 40% of the vehicles are, and the accidents that are occurring in vehicles are due to side collisions. And due to these collisions, there have been 30% of like near-death accidents that have been taken place. And for this reason, we need side airbags, which is not a much common feature in today's vehicles. We need a better design for this because suppose in a forward-facing airbags, we would see that there would be a much better protection because we are protected by the hood, by the bumper, and so the collision or the impact would be a little less. But here in side collision, we would be directly in contact with the door and the cushioning of the door. So based on this, the reaction time of the airbags must be very little. And the sensors used here are mechanical sensors, which will detect the collision like in 5 to 6 milliseconds for it to be effective. And collision speeds from 12 miles per hour and onwards would be taken into consideration while deploying these kind of airbags. There is another added feature for this, wherein there is an air head bag that is deployed once collision takes place, and this is kept in motion for like 5 to 6 seconds after the collision to avoid any secondary collisions that are coming in between. After this, there is another concept that I wanted to introduce, seat belts. Seat belts are like the most basic things that are used in vehicles today, but there is another addition, like this is pre-collision technology. Like prevention is better than cure, so this is what we'll be talking about in the seat belts, wherein suppose if the collision is imminent, like you're coming towards a car and you know by sensors that the collision is imminent, suddenly there will be a tension increase in the seat belts, which will pull the person backwards to the seat so that he, on collision, wouldn't bang or his head onto the dashboard, and this would definitely help in saving his life in case of a collision. Previous slide. Now these are certain technologies that I've spoken about that are already there. There might be in some vehicles that are developing, but these are certain technologies that have not come out in the market. They are just in the research stage, and we would like to exploit these technologies in our vehicle to make it a completely futuristic vehicle. To start off with, I would talk about the rotatory car doors or the sliding car doors. Now, these car doors are the future of door technology, wherein we will be the doors, rather than opening towards the side or opening toward the top, these doors would be sliding into the panels of the vehicle. The most efficient structural form is a tube or a fuselage. Ease of entry or egress is achieved by lowering the sides of the hollow forms and then releasing and then structurally reintegrating them and thereby returning them to their proper shape. Now, this technology is very efficient in terms of the overall improvement, and the stiffness of the doors is very high. The safety of the door operations is much more better, like there won't be any collision with the other vehicle while you're opening your door. It would just slide inside. Now, these vehicles take into account an obstacle if it is coming in between the operation of the door, then it will stop and then it will continue once again if the obstacle is removed. Now, there will be no door dings, like once you're parked, you're wedged in a space, you want to open your door and you just hit the other car. So this won't be taking place, as they will slide directly inside the panels. And consider a very crowded parking spot. You have very less space to park, but you have no space to open the doors. So this technology will take care of that, because there won't be any space required for opening or closing the doors. This is here as an example wherein the person can directly get down from the car when the door slides inside, and there would be no opening or closing of the door, and this also improves the easiness of the operation. Invisible car. This will definitely take you back to the James Bond movies, wherein people were so amazed by the concept that they had introduced. Although it was science fiction, but now it might be a reality in the near future, where we will be having an invisible car. Now this car it would be really cool for military operators to get into zone being unnoticed, and this would be the way to go about it. This technology uses LED mats all over the vehicle, and there will be a camera mounted on one side of the driver's side of the vehicle, which will shoot the image from his side and project it on the other side for the passenger side. So then what we are talking about is projecting one side of the image to the other, and thereby camouflaging the whole vehicle to the surroundings. So it will be, although they do need to work on the wheels of the vehicle, wherein they cannot be completely concealed, but certain research is being carried out in this field so that the entire vehicle can be camouflaged to the surroundings. And this is something that we would really incorporate in our vehicle, which would improve the coolness factor of our vehicle. Now we come to the self-inflating tires, which were again talked about in a James Bond movie, wherein the nails get into the vehicle and the tire just inflate again. So this is not quite the same, but it serves the same purpose. Here we would be having self-inflating tires which are based on the peristaltic pumping principles. These pumping principles suggest that the weight and the movement of the vehicle is enough for tire to completely inflate itself again. It requires basically two components, mainly the peristaltic pumping tube, and then the tire pressure management device, which will be required to maintain the pressure of the vehicle, pressure of the air inside the tires, and the tubing is placed longitudinally between the rim of the tire and the tubing of the vehicle. And now deformation will be caused at the lowest point of the tube, which will result in pushing the air inside the tube into the tire, and at the same time take in air from the outside atmosphere. Here we won't need any auxiliary device to put in air into the tube. The air that we'll be using will be from the outside, from the atmosphere, so it will be like a green solution for air. And due to this, as the deformation continuously keeps on taking place, air will be pushed inside the tire. At the same time, air will be pulled from the outside environment into the tube. So there will be continuous inflating of the tire until a certain pressure, a suitable pressure is reached, and at that time, the pressure management device can stop the flow of air from the outside atmosphere, so that we have efficient pressure inside the tire. This is very important because suppose if you're lost, if you have a flat tire in the middle of nowhere and you run out of spares. So this mechanism will definitely get you to the nearest car station so that you could change your vehicle. Also, it improves the fuel efficiency by a percentage of almost 15%, which is pretty huge, and this is something that would really incorporate in our car. Parallel parking. It has been there for a long time, and many technologies have been taking place. It requires mainly twisting and turning of a vehicle into a parking space. But what if there is no space for twisting and turning? You are wedged in, you have a very small space and you need to get in, there are no other parking spots, what would you do? This technology takes care of that. When it basically uses four-wheel drive, it has servo motors attached to all the four wheels, and it basically works like this, like a vehicle is coming and parks near parallelly to a parking spot, and then by activation of the motors, all the wheels of the vehicle will turn by 90 degrees, and then when you drive, you'll just slide into the position so that we don't have to have any twists or turns. So this is one major improvement. The other thing is that suppose if we are twisting the angles of the vehicle to a particular end, and suppose you're crammed up in a space where you want to take a U-turn. So by changing the orientation of the wheels to a certain degree, and each angle will be different, we can rotate the car 360 degrees and turn back and go out of the place, because we don't have any other space to go around. So this is another feature of the vehicle. And now all these technologies, although they're in the research stage and they would be a bit difficult to incorporate on the design level, I think this would be major improvements in our vehicle, which will be focused towards a complete autonomous vehicle. So I think these technologies will be very important for our vehicle, which is the Transcender. Thank you.
For watching our presentation. We believe our vehicle, the Transcender, will transcend all the consumer demands of the future.
I would like to include two members of our design team who couldn't be here, Vikrant Pavaskar and Tanner Boone. Their contribution has been important to this presentation and this report, so I would like to give them due credit for this.
We are Group 5. Thank you very much for watching. We hope you enjoyed it.